So can you see the web browser and the
Yes,
terminal?
yes, both of them.
So,
Yes.
okay, we will now go to the next section, which is packages and isolated environments. And we will provide you with a general theoretical introduction to the isolated environments. We will show you how to install your own packages and also how to check for Julia packages at either UPPMAX or HPC2N, and now also at LUNARC. So Julia packages and environments. So if you want to uh, increase the scope of your current program, so you can use the existing packages in the Julia ecosystem instead of writing the code yourself. Isolated environments work in a similar manner in Python than in Python, and they solve several problems. For instance, here you can install specific older versions of packages. You can create one environment for each project because they are lightweight in Julia. So there is no problem if you have several projects, so you can have different versions, yes, for your software and create a single environment for each of them. And because they are lightweight and they consist of simple files, then you can remove the environment just by deleting the files that are created in the environment. And it's not a big issue here. So so if you're familiar for Python, or if you attended the lesson yesterday, you saw that there are Python has several tools to deal with isolated environments. For instance, one can talk about Conda and also env environment or virtual environment, and 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 there are several tools. And so here in Python, it's common that people combine Conda and PMP, for instance, which can uh, make the situation a bit difficult when you want to to install the same packages that you had in a previous project into a new project. For instance, if you move to a new machine. So the situation is simplified in Julia because Julia provides its own way to manage environment. And in particular, Julia distinguishes between one environment, which is called project environment, and also another one that is called package environment or package directory. So if you want to know more about these environments, you can go to this link here to the Julia documentation. And the difference, or the main difference between these two types of environments is that in the former, or here in the project environment, only the TOML files are present, while in the latter, in this package directory, one also include the source files. For instance, if you are developing your own code, and this code uses other existing packages available in Julia. So packages are imported or loaded. Yes, these are two important words, imported or loaded, by the commands import and using. So they have a different functions. So the main difference is that if you use import, you still need to type the module name, right? Every time you want to use a function from that name. While if you use using, in that case, the module name gets available into the current namespace, and because of that, you only need to type the name of the function without the module as a prefix. So this can be also useful import. For instance, if you want to get specific functions from that module and you don't want to create overhead when you try to load the entire module as with using, right? Some modules are relatively big. They contain many functions, and you don't need to import everything, right? Just specific functions. So if you take a look at your home directory, which is where by default the Julia configuration files and the Julia stuff is stored. So you can see that it contains several folders that are created the first time that you load Julia. So this is more specific, and this section here, or the what I will talk about in the following paragraphs, it's more specific and also more advanced, and it is needed just in the case where you want to have a strict control on the packages that you are installing. For instance, if you are a code developer in Julia and you want to have specific versions, right, of some package so that when you move to a different machine, yeah, a different HPC center or even in your laptop, for instance, then you know exactly what to load because packages can be different with the slight variation of the versions. So packages in Julia are decentralized and they are labeled by a universally unique identifier, and they in Julia terminology is called UUID. And in that way, Julia knows what package to refer to. So the active environments can be seen with the command load path. If you go to Julia, the Julian mode that Bjorn mentioned before, and then you try to execute this command, you will see all the environments that are available in your session. For instance, here, I will try on the terminal, the command Julia. So it's not found because I haven't loaded the module. I can load the module. Then start the Julia session. And here I type load path with capitals. And here you can see the environments that are available. Add refers to the current environment. This symbol here is the default environment for the Julia version. And this stdlib refers to the standard library that contains, for instance, the print command, which is very basic and it's available in the standard library. So there is some nuance at UPPMAX because here the UPPMAX has a central environments that add to the list. So if you do this, you execute this command load path at UPPMAX, then you will see this environment as well. So in addition to the current environment, other environments are present, as you can see here. So in this case, there are three, and at UPPMAX there are four because one is added. Yes. And because there are several environments that are available, then there could be some possible conflicts for reproducibility. For instance, if you need something very specific for your code, right? And you don't know you know that in one project you use a specific version, and then your code is not working any longer, or it's not working in the same way as before. So how to avoid this situation where you have some possible conflict with reproducibility? In that way, you can control exactly what you do in Julia. So as I said before, these paragraphs, yes, are for strict control. And in general, if you do the basic things with Julia, you don't need to pay attention to them, right? So Julia will manage the packages in a very efficient manner. But if you want a strict control, then you can follow the following paragraphs. So imagine that you start your project in a fresh installation, which means that you remove the .julia folder that I mentioned before, right? And then you start Julia without any install module. In that case, if you use that, for instance, using PKJ, PKJ is the package manager in Julia, and this will make the namespace of PKJ available. And then you can call the project function, and it will give you information of all the packages that are available in this Julia session. Because this was a fresh installation, right? You can see that nothing has been installed. Yes. So basically, there is only a path to my environment, the global environment here, and it says that nothing was present at this point. So, but now let's move on with these installations, and we will try to add or install a package that is called DFTK. And if you are curious about that, it's just a software for doing some density functional calculations. You can find more information here, but this is just a general package that I want to install. And here you go to the Julian mode, load the PKJ module, add then the DFTK module, and you will see that this takes some time, like 5 minutes, to install this package because it has several dependencies, right? And remember that we started with a fresh Julia installation. So now if you go to the Julian mode and type again pkj and the function, then you will see that something was added here, and this was the DFTK package, and the universal identifier is here present, and DFTK point to its ID number, which is this long number. In this way, Julia knows exactly what version of DFTK is installed in your project. So previously I mentioned that Julia distinguishes between project environments, right? And also project environment directories. And here I make a brief explanation of what they are good for. So these will be needed if you want to create a project. And this is recommended if you're developing your code, because here you can have a control of the packages that you install. So here you can start typing along. So here, as you can see here, I am in the shell mode, and Björn mentioned previously that you can get the shell mode by typing the semicolon, and then it will turn to the shell prompt. Here I can type, for instance, make dir, my first environment. Yeah. And then I am still on the shell mode. Here I can type the cd to move to the folder, right? And then it tells me you move to that folder. Then I return to the Julian mode and load the pkg package. I go to the shell again, right? And here there are some comments to tell you what you need to do, right? This is just a comment. And then you go to the Julian mode. Yeah. No, sorry, you go to the package mode. Yes, by typing this symbol here. And here you can see that you're in the package mode. And here you activate the environment. And as you can see here in the prompt, the label was changed from the general environment 1.8 to the name of the folder, which is taken as the environment name, which is my first environment. And here I can go to the shell mode, type ls, and you can see that it is empty. It's empty up to this point. Then return to the Julian mode. So here you can see that the environment has been activated. Yes, and then you can start doing things within the environment. So the first thing that we can do is to take a look at the available environments that are in the current installed environment. Here you can see that as previously, we have three elements, and at UPPMAX you should see four, and these were mentioned before, right? And now we can start installing the modules that we want. In particular, we will add the DFTK. For this, we go to the PKJ mode, or the package installation mode, or package handler mode. And here we add the FTK, right? And it will install the FTK package, but within this environment, right? So if you do this for the first time, installation of the SDK will take several minutes. But in my case, I installed that previously. And because of that, this is your refreshing or updating the TOML files present in the current directory. So so now we can take a look at the content of the directory. Once This installation is completed. Now it's completed. Now we can go to the shell mode, and we will take a look at the content. And you can see that there are two TOML files, right? Which tells you about the project content. So you can type, for instance, project TOML, and you can see that DFTK was added, and this is the UUID for DFTK, right? So this is a general file for the project, right? But a more specific file for the project so that you know everything that it is inside or it's required for this content, right? So this information is in the manifest TOML file. Here there is more information, for instance, the Julia version, the hash for this project, also everything and all the dependencies that were needed for this particular package with DFTK. You can see that linear algebra was used with this UUID and this version, and also other dependencies. So this is more specific. So you shouldn't modify this file manifest because you can affect the project status if you move, for instance, to a different machine or to a different computing center and you want to reproduce your results. So here, uh, here you can see how to activate the project. For instance, if you go we have seen this way by running activate, right? You activate the project, or if you already have the environment and you have a Julia script and you want to activate the environment within a Julia script, then you can include these lines here. PKJ, activate, and dot. So we can do it. So we can exit this session, for instance, then start a new session. And at this point, I don't know what is the environment. So here I go to the package mode and I see that this is the global environment that is being used. And if I want to activate the environment, I can run again pkj.activate and then point to the current directory. So now if I move to the pkj environment, I can see, okay, so sorry, because in this case, no, I need to move to my first environment, yes, because I was not in this folder. Then I start the Julia session. I move to, no, I import, no, load the PKJ, and then UPPMAX activate. Then if you see here, I am activating the environment that I created before. And if I want to know the status of, oops, it's here, PKJ status. You can see that we have in this environment the FTK that we installed previously. So besides the project environment, we also have, or Julia also has the so-called package environment. And here, the main difference is that you can include the source files in case you are developing a module, right? So the way to do this is by going to the Julia mode, to the package mode, sorry, and then you type the command generate and the name of your package. So this is a bit more strict because here you cannot use dashes, right, to call to give a name to this package. So and that's why I use my first package without dashes. And then you will see that the two TOML files are generated and also a folder called SRC where you would include the source files, right, of your project. In this case, it's just an example, and it's called my first package and .yal. So then you can move to the folder, activate the environment as we did before with activate dot, and you will start in this environment. Then you can check the status, and in this case, you will see that nothing has been installed, and you can start adding some packages. For instance, in this case, I added the package called Flags, which does some machine learning routines. And then you can check the status after adding the package, and you can see that the Flags was added with this version here. So besides the two environments that we mentioned before, the project environment and the package environment, so we can use the other environments that are available. As we saw before, that at UPPMAX there is an additional environment. We can customize the environments that we have by adding them to the path, right? But again, this part specifically is more advanced, and it's just, for instance, imagine that you don't want to use the the environment that is installed at UPMAX, but you want to use your specific version of your function, right? In that case, you can control that by modifying this path. You can even set this path to a single value, which is the current environment, to avoid everything extra, yes, from the existing cluster, for instance. So, and these are ways to empty the the path to the environments and also to put something into the path, right? So by doing this and by using this variable here, load path, then we can stack different environments. So as in the case of the UPMAX environment, you can see that besides the three environments that are there by default, you added one more. So you stacked an additional environment, and you can do it with other environments as well to increase the ecosystem of your own package. So here was one way to deal with these stack environments. And here there is some notice for the central library at UPMAX. And this is because at UPMAX, especially on this machine Bianca, so you cannot install the packages from internet, and because of that, the packages or most common packages are already there, so you can import the packages without doing any installation, and that's very useful. Here is how to access these packages. You can use a PKJ and then activate the environments. This is quite useful, I would say, in machines like Bianca. There's a list of the packages that you can get at UPPMAX, right? By default. And here is a notice for LUNARC and HPC2N, where here in these two clusters, only the base and standard libraries are available for Julia. So you will need to install all of these packages if you want to use them, right? So here there are some exercises that you can try. So thank you.
Yeah, I have one question.
Yeah.
So when you have activated an environment, can you easily deactivate it within a session without quitting Julia?
You can type uh, activate, but without anything, without
Aha,
any
okay. Yeah,
value. Yeah.
because deactivate was not there, like we
No,
have in
no, no,
Python. So,
no. You can use
so
anything.
activate nothing.
Yeah.
Okay, that's good.
Mm-hmm.
We should put that to them. Yes,
Mm-hmm.
thank
I
you.
will stop sharing.